Hello friends, so we meet again. I am Sanjay Agarwal and welcome to Sanjay Agarwal Maths classes. If you have seen the previous episode, you know what we are doing in the class. We are doing vectors of class 12. In the previous section or previous episode, I have called it as episode number 1. We started with the introduction of vectors. Now this is episode number 2. Time duration will be approximately 30 minutes and we will continue from the previous episode where we left. So if you are joining now for the first time, you go back and watch the previous episode and then you watch this episode so that you understand what's happening in the class. Otherwise, if you have not studied vectors before or you are a non-physics student, you will find problems in understanding. So in the previous chapter, let me give you a brief summary of what I did. I described what are vectors, what is the difference between vectors and scalar quantities. How do I represent vectors geometrically? What do you mean by vectors such as null vectors, unit vectors, negative of a vector? I described what is I cap, j cap and k cap. I cap is a unit vector. Unit vector means a vector whose magnitude is 1. I cap is a unit vector of magnitude 1 whose direction is along x axis in the increasing direction of x. So, all this we studied in the previous class. Null vector is a vector whose magnitude is 0. Now, we will carry forward from here. Now, the topic for the definition for now is co-initial vectors. What are co-initial vectors? It won't be used in any numerical. Co-initial vectors are those vectors whose starting point is same, like this. So, these 3 vectors all are starting from the same point but are going in different directions. And what are So, these are just the terms, you should know it once. If you forget after 5 minutes, it makes no difference. Coterminal vectors. Coterminal vectors, as the name suggests, will be like this, which terminate at the same point. So, I can say in the morning when students come from different direction to their school, they are all coterminal vectors. When there is a bell and the school ends, all the children, specifically the kindergarten students, will be rushing out from their class, running in different directions, but they will all start from the same point. So, they will be co-initial vectors. So, you know what is co-initial vectors and coterminal vector, but it has no significance in any numerical. But still, it is a terminology. There is no harm in knowing the terminology. All right. Now, we talk about the most important aspect of the vectors, which is called position vector of a point. This will be used in almost each and every numerical. All right, let me draw x axis, y axis and z axis, x axis, y axis and z axis. This is 3-dimensional coordinate system x, y and z, and they are all mutually perpendicular to each other. This is called origin. Now, suppose I have a point P here, all right, and this is origin. So, what is the position vector of point P? The question is, what is position vector of a point P? So, what is the answer? From the origin, you take a scale and join P with a straight line and put an arrow towards P. Now, this has become a vector because this is a line segment of a definite length and it has a specific direction which you can see on the blackboard. So, position vector, which I can write it in short like this, position vector of point P, I will not write the word P, is vector OP. So, every point will have a position vector. Suppose I have another point here, Q. So, you join origin with Q, put a arrow towards Q. So, what will be position vector of point Q? It will be vector OQ. So, length of OQ, which will be the magnitude of vector OQ, will give the distance of point Q from O, and the direction will be physically seen in the diagram. So, every point has a position vector. So, this is clear to you. So, the position vector of point P is vector OP, position vector of point Q is vector OQ. I put a point R here, position vector of point R will be vector OR. When we go further, deeper into the vectors, suppose I have a line segment here AB. Let me make separate diagram for you. Okay, how do we write position vectors? See here. Let me draw a two-dimensional coordinate system for the time being. X minus y. This is the origin. Suppose I have vector AB like this, A and B. This is vector AB. Alright, I join this, so this becomes vector OA, which will be called as position vector of A, and if I join this, this will be called position vector of point B. So what is position vector of A? It is vector OA. What is position vector of B? It is vector OB. Alright, when I am doing numericals, I won't be drawing this diagram. What will be happening? I will draw vector AB like this, say vector A, vector AB I will draw like this, tail, head, initial point, terminal point, direction will be shown by this arrow. I won't show actual direction. So, this is a representative vector, this is vector AB. Now, what is position vector of A? OA. So, if I want to show OA, I will have to draw x axis, I will have to draw y axis, I have to draw mark origin and join origin with A. Instead of that, below the point we will write it as OA. So, if below the point I write any vector that will represent the position vector of that point. So, physically we are not going to draw x axis, y axis and OA and OB, and this will be OB. So, this is the way I am going to write position vector. So, if below a point in the bracket I write a vector that is understood to be the position vector of that point. Sometimes we will write position vectors with a single letter. Suppose this is again vector AB. Let me write A slightly above. This is vector AB. Suppose I write below A vector like this. So, it is understood that this is the position vector of A. Means OA has been represented by a single letter, small case letter. If I write B below it, it is understood that this B is nothing but vector OB. So, position vector of any point is a vector which is obtained by joining origin to that point with the direction. So, position vector of A will be vector OA, position vector of B will be vector OB, but while doing numericals, we are not going to draw x axis, we are not going to draw y axis, we are not going to physically draw vector OA or physically draw vector OB, we will physically draw vector AB and below A in the bracket we will write OA. So, that will indicate position vector of A. Alright. So, next topic, expressing any vector in terms of position vectors of its endpoints. Expressing vector AB in terms of position vectors of its endpoints. Okay. So, I will draw the previous diagram once again. You know, the interesting part of this is the moment you start handling vectors algebraically, that is every vector will be expressed in terms of I, j and k, then developing formulas, doing numericals are far more simpler than what I am doing on the blackboard right now. I could have skipped all these parts and straight away given you formulas in terms of unit vectors I, j and k, but it is good to understand the geometrical concept of the vectors before we dive into algebraic portion of the vectors. Now, you see, I am drawing x axis, I am not drawing z axis, just to make things simple for you. This is vector AB, I just do this diagram, alright. So, I put an arrow like this. So, this is vector OA, call the position vector of A. This is vector OB, call the position vector B. After this topic, although I am using it now, the moment I finish this, I will teach you how to add two vectors. So from that vector addition, I get a statement. Vector OA plus vector AB is equal to vector OB. This is called triangle law of addition. So I am using it now, but after I rub off this diagram, then I will teach you vector addition of two vectors. How to add two vectors with the help of a diagram, and later we will add two vectors very quickly when we express the vectors in terms of I, j and k. This is called triangle law of addition. You start from O, not A, you start from O, go to A in a straight line, then you start from A and go to B. So you cover vector OA, you cover vector AB, and then you just rest here. So OA plus AB, what is the answer of vector, sum of vector OA plus vector OB geometrically? It will be the shortest distance from the starting point to the finishing point. Shortest distance is always a straight line distance. So you suppose this is the market here and this is the mall here. You go from your home like this, reach the market, from market you go to the mall and you just terminate here. Now your mom comes to see you where you are, so she comes by the shortest distance like this. So this line segment has a definite length. We have put a direction also because you are moving from O towards B. So this vector OB will be called sum of vector OA and OB. OA and AB, not OB. So OA plus AB will be equal to vector OB. This is called triangle law of addition. I will take it separately once I go through this diagram, but still I explained this line to you. So vector OA plus vector AB is equal to vector OB. I am again repeating, the moment you start the algebraic portion, when you represent the vectors in terms of I, j and k, it will be very fast, it will be very easy for you. So vector OA plus vector AB will be equal to vector OB. Now you rearrange it. So what will be vector AB? Vector OB minus vector OA. So this is the topic. Every vector can be expressed in terms of position vectors of its endpoint. So what is vector AB? So let me write it a formula for you. What is vector PQ? I can call it as position vector of Q minus position vector of P. If you are representing with two alphabets, so this will be OQ minus OP. Okay, suppose you have vector say RS. So I can write vector RS as position vector of S minus position vector of R. If I use the symbols, it will be OS minus OR. So every vector can be expressed in terms of position vectors of its endpoints. Alright. So now even if you don't want to understand this line, this formula is good enough. PQ is equal to position vector of Q minus position vector of P, because this I will be doing in numericals. Many numericals I will be using this expression. Expressing a vector AB in terms of position vectors of its endpoints. So now we have done the first basic portion of the vectors. What are vectors? What do you understand by the magnitude of the vectors? What do you understand by free and localized vectors? How do you represent vectors geometrically? And what do you mean by equality of vectors? What is a null vector? What is a unit vector? What are three spatial vectors I cap, j cap and k cap? What do you understand by the position vector of a point, and how do you represent every vector in terms of position vectors of its endpoint? So you can say stage 1 of vectors is over. Now let's try to add, subtract and multiply vectors. That is a natural progression. Once you understand, learn in kindergarten your numbers 1, 2, 3, 4, 5, 6, then you start learning how to add them, then how to subtract them, how to multiply them, and finally how to divide them. But we don't have any concept of division of vectors. We do have concept of addition, subtraction and multiplication of vectors. So let's try to add vectors. What are the rules for adding vectors? That I just now explained it to you also, but again we will take up this topic. So So next topic is addition of two vectors. How do I add two vectors? Okay, suppose I am given a vector A, let me represent it by a small letter, and a vector B. Okay, so they have specific length and they have specific direction, you want to add them. So there are two rules to add vectors. One is called addition rule. No, not addition rule. One is called triangle law of addition. And another is called parallelogram law of addition. So you have triangle law of addition and you have parallelogram law of addition. Now let's first do triangle law of addition. I am given vector A, I have been given vector B, I want to add them. Now how you are going to do is, you are going to move vector B so that its tail, this is the tail of this vector, coincides with the head of this vector, and vectors can be moved freely in the space as long as you don't change their magnitude and direction. So what I am going to do is, I am going to pick up this vector and draw it here. So like this, alright. So they have to be parallel to each other and their length also should be same. So this vector is one and the same thing, then you can just remove this vector from here. So I have moved this vector here. Okay, so I can say one after the another, say a series connection A and then B. So you start from A, you come here, you go there and you rest here. Now the shortest distance between the starting point and the finishing point along with the direction will be called the sum of the two vectors. So this is the sum of the two vectors. I can give it a symbol, say arc, and that will be A plus B. Sum of the two vectors is also called resultant of two vectors. You must remember sum of vectors. I can add three vectors also, but right now let us start with adding two vectors. Sum of vectors is also called, please remember it, sum of vectors is also called resultant of vectors. I do remember an episode, I gave this question, one question in the exam, and I asked my students, find the resultant of the vectors. So many students got confused, they could not write the answer because they forgot that resultant of the vectors also means the sum of the vectors. So just simply forgot. So I am emphasizing this point, sum of the vectors also may be called as resultant of two vectors. So this is called triangle law of addition. We have a proper definition in class 11 physics which we need not learn in class 12 maths. If two vectors are made to represent the sides of the triangle, consecutive sides of the triangle in a specific direction, then the third side taken in the reverse direction is called the sum or resultant of the two vectors. So if I use capital letters for the endpoints that you see here, same diagram I am making, it is a little bigger anyway, let us ignore that. This is A, this is B and this is C. This is vector AB. Instead of representing by a small letter, I am representing by two capital letters. This is vector AB, this is vector BC, this one, and this is their sum. So I can say vector AB plus vector BC is equal to vector AC. AB plus BC. You go from A to B, then you go from B to C, then finally shortest distance between A and C, that is vector AC, will be the sum of two vectors. So this is called triangle law of addition. Now what is the next rule? Parallelogram law of addition. Again I am telling you, once we get over with this, which is a little overwhelming for you in the beginning, and when we start the algebraic representation of vectors, that is in terms of I, J and K, addition of vectors will be so quick that you will be amazed. And then some of you may start thinking, why sir wasted our time in explaining triangle law of addition, parallelogram law of addition, because when you are doing numericals, these will not be required. Many years ago, there were numericals in the exam where we were using triangle law of addition and geometrical representation of vectors, but for last more than 10 years, that portion of the vectors has been deleted from the syllabus. Just for a moment, I am telling you, I am going to come to this point later. Suppose I have a vector A and I have a vector B. See, every vector eventually, but this I am going to come up later, so don't get worried. I am just bringing this point out of context to show you how easy it will be to add vectors when we are actually doing numericals. Every vector will be expressed in terms of I, j, k. Suppose vector A is 2i. How do we do it? I will tell you later. 3j plus 2k. And there is another vector I minus j plus 5k. Every vector, I mean 1000 vectors, every vector will be in terms of I, j and k. Now if I ask you, you have to add two vectors. You don't need any diagram, you don't need triangle of addition, you don't need parallelogram law of addition. I am sure if you were sitting here in the class physically with me, every child by instinct would have given me the right answer. So you know what you are going to say, a plus b, 2i plus I, 3i cap plus 2j cap plus 7k cap. So this is that simple. So you will be wondering why we are doing triangle law of addition, why we will be doing now parallelogram law of addition when adding two vectors is something which is so obvious, it comes by itself even if nobody tells you. Similarly, in the same context, if I say what will be a minus b, I am sure each and every child will give me the right answer even without knowing what is triangle law of addition, what is parallelogram law of addition. So I am sure what answer you are going to give. 2i minus I cap minus 3j cap minus or minus j cap will become 4j cap and this will become minus 3j cap. I am sure all the students who are right now watching this video or this lecture will be giving the correct answer. So it is so simple to add and subtract two vectors when vectors are expressed in terms of I, j and k, but when vectors are represented by directed line segments, we need rules, triangle law of addition, parallelogram law of addition. So I will rub it off and now I will do just for the sake of doing it so that at least you are aware what it is. Let us do after triangle law of addition, parallelogram law of addition. Again, let me take two vectors, say vector A and vector B. In triangle law of addition, I push this vector like this. Now I am going to push this vector here. That is, I am going to make them as co-initial vectors. Okay, so this is vector A, this is vector B. Instead of pushing it here, I push it here. Alright, now with the help of a scale and a pen or a pencil or some other instruments, you complete a parallelogram. So this parallelogram is done. Let me give some names to the corners A, B, C, D. Alright, if this is vector B, this also will be vector B. You know it why? Because opposite sides of the parallelogram are of same length and they are parallel, and I am putting the direction in putting the arrow in the same direction. So vector AD is same as vector BC because they are same magnitude and they are parallel with the same direction. Now draw this diagonal, put an arrow like this. Now by triangle of addition, vector AB, this one, which can also be called as small a, plus vector BC, which can also be called as small b. So now this is series connection, A to B, B to C. Then the shortest distance between the starting and the finishing point, that will be vector AC. So this is called, this portion is triangle law of addition, but I obtain it by completing a parallelogram. So this is called parallelogram law of addition. You complete the parallelogram, then the diagonal passing through the common initial point is called the sum or the resultant of two vectors. Now the question arises, the other diagonal BD, does it have any significance? Does it also represent any kind of vector? Let us have a look at it. Now let me draw this diagram again here, slightly bigger diagram I am making. Okay, A, B, C, D, and let me draw this. So this is vector A, this is vector B. Alright, let me put an arrow like this. You can put an arrow from D to B also, choice is yours. Now by triangle law of addition, can I say vector AB plus vector BD? See, you go from A to B, then you go from B to D, you rest here, then the shortest distance from the starting point to the finishing point, that is AD, will be with the arrow, will be the sum of the two vectors. So vector AB plus vector BD will be equal to vector AD. Now you take AB on the other side. So what will be vector BD? AD minus AB. AD minus AB. So vector BD will be AD minus AB. That also becomes subtraction of two vectors. So when you do parallelogram law of addition, both the diagonals have a meaning. The diagonal passing through the common initial point will represent the sum of the vectors, and the other diagonal will represent the difference of the two vectors. And again, when I am doing numericals, when I represent the vectors in terms of ijk, I don't need any rules. I don't need triangle law of addition. I don't need parallelogram law of addition. I can simply add them like this. And you just saw an example also. So I will rub off the parallelogram law of addition from the blackboard. So we covered how to add two vectors by triangle law of addition and by parallelogram law of addition, and also we saw the subtraction of vectors by the second diagonal. Alright. Now suppose, I guess we will finish the class here because it is almost 30 minutes. So episode number 2 on vectors, the theory of vectors, the geometrical representation of vectors, we will be ending the class here, and in the next lecture we will carry forward from here. I am sure in the next lecture all the boring portions of the vectors will be over, and then from the 4th episode it will be very interesting for you because we will be starting the algebraic representation of vectors where we are going to represent the vectors in terms of I, j and k. So please, you can go through this video again and the points will be clear to you. If you have any doubts, you have any suggestions, please feel free to write in the comments. You can even drop me a mail. The email ID will be mentioned in the description, and do subscribe and hit the bell icon also, so that you don't miss the future episodes coming on vectors and other chapters of class 12 maths. I am very hopeful and sure also that you will be really benefiting from watching and trying to understand these lectures. Okay, bye for now.